Welcome back, team! In our last chapter, we explored the fascinating world of neuroscience, learning about the brain's structure and how neurons and glial cells work together to create thought, movement, and emotions. Today we're diving into the mind-bending world of quantum computing. Let's start with a riddle. How is a quantum computer different from the one you're using right now? Classical computers think in zeros and ones, on or off, but quantum computers use qubits, which can be in both states at once. This magical trick gives them the power to solve really hard problems super quickly. Imagine solving a huge puzzle in seconds. Let's explore how quantum computers are changing the game in computing and the problems they can solve that classical computers can't even dream of. Quantum theory is all about the tiniest parts of our universe. We're talking atoms, electrons, and even smaller things. But here's the twist. These particles don't behave the way we expect. They can do tricks like being in two places at once or instantly talking to a twin particle miles away. This strange behavior might seem magical, but it's the real science behind many of today's technologies, from super-fast computers to lasers and MRI machines. Quantum theory can seem totally bizarre. Imagine a coin spinning in the air. It's both heads and tails until you catch it. That's kind of what superposition means in quantum physics. Then there's entanglement, where two particles are mysteriously linked, even if they're on opposite sides of the galaxy. And finally, Heisenberg's uncertainty principle tells us that we can't know everything about a particle at the same time. It's weird, it's wild, and it's all real science. Imagine you toss a pebble into a pond. You see ripples, right? That's how particles act when they behave like waves. But now imagine a tiny ball bouncing. Sometimes those same particles act like that too. This is the weird world of wave-particle duality. Scientists discovered that tiny things like electrons can act like both waves and particles, and it all depends on how we look at them. Superposition is one of the coolest quantum tricks. Imagine flipping a coin and not knowing if it's heads or tails. In the quantum world, it's both. Until you look. Qubits in a quantum computer can be in a blend of 0 and 1, which gives them the power to explore lots of answers at once. That's why quantum computers are so powerful. Quantum entanglement is like magic. Imagine two twins who always know what the other is doing, even if one is on the moon. When two particles are entangled, they stay connected no matter how far apart they are. If you do something to one, the other reacts instantly. This was so strange that even Einstein thought it was spooky, but scientists have proven it's real, and it's used in quantum tech today. Here's a brain twister. Imagine trying to take a perfect picture of a racing car, but every time you focus on its speed, the image gets blurry. That's kind of what Heisenberg discovered. In the quantum world, if you know exactly where something is, you can't know how fast it's going, and vice versa. This isn't because our tools are bad. It's actually how nature works at tiny scale. In our everyday, classical world, things are pretty predictable. Cars drive, balls bounce, and apples fall. But the quantum world plays by completely different rules. Instead of knowing exactly what happens, we talk about chances. A particle might be here or there, or even in both places. It's like living in a world where everything is a mystery box. Let's talk computers. Classical computers think in bits. Each one is either a 0 or a 1, just like flipping a switch on or off. Quantum computers use qubits. And here's the twist. They can be both 0 and 1 at the same time. That means they can do a lot more with fewer pieces. Kind of like being able to read every page of a book at once instead of one at a time. Trying to picture a qubit? Think of a tiny globe that's spinning in all directions at once. That's the Bloch sphere. A fun way scientists imagine how qubits behave. Unlike a regular bit that's just on or off, a qubit can be in a mix of states, pointing anywhere on this sphere. It's this spinning magic that helps quantum computers pack in lots more information. When we combine superposition with qubits, we get serious computing power. It's like being able to try every combination on a lock at the same time instead of one by one. Quantum computers use this trick to solve problems that would take regular computers forever. From finding the best routes to discovering new medicines, it's a superpower for science. Think of quantum logic gates like Lego blocks for building quantum computers. Each gate does something special to a qubit. Flip it, rotate it, or mix it up. When we connect these gates in a line, we make a quantum circuit that can solve really big problems. It's like building a robot brain, but for quantum thinking. Quantum circuits are like obstacle courses for qubits. Each gate in the circuit changes something about the qubit. Maybe it spins a little, flips it, or mixes it with another. By sending qubits through a specific sequence of gates, we can solve problems and do calculations. At the end of the course, we measure the qubits to see what they've discovered. Here's a fun and simple quantum circuit example. We start with a few qubits, usually all set to 0. Then we apply some special gates, like Hagamark to create superpositions, and C0 to entangle them. Finally, we measure the result to see what we get. It's like a recipe. Qubits plus gates plus measurement knows a quantum answer. Building quantum computers is like trying to whisper during a thunderstorm. Qubits are super sensitive. They need to be kept colder than outer space, and even the slightest noise or heat can ruin everything. Plus, we still don't have a good way to make hundreds or thousands of qubits work together without errors. That's why quantum hardware is one of the biggest challenges scientists are working on today. Quantum cryptography is like magic mail. If anyone tries to peek, you'll know instantly. It uses special quantum rules like entanglement to keep information super secure. This tech is perfect for things like online banking and secret government messages. Even the best hackers can't break it without being caught. Imagine trying to find a book in a giant library. A regular computer would check one book at a time, but a quantum computer, it checks them all at once. Quantum search uses superposition and entanglement to scan massive datasets much faster. It's like having a million searchers helping you all at once. Let's recap our quantum journey. Quantum theory explores the tiniest parts of the universe, where things behave in super strange ways. We've seen how habits can be in two states, how particles stay connected no matter how far, and how this leads to amazing tech like quantum computers and ultra-secure encryption. These ideas are shaping our future, and you've now got a sneak peek into it. Time to test your quantum smarts. Can you remember what makes a qubit special? Or why quantum computers need to be freezing cold? What about that spooky action across space? These questions will help you lock in the cool facts you've learned on this quantum adventure. Here's your mock exam challenge. You've learned all about how weird the quantum world can be. Now tell me, what's the name of the principle that explains how those tiny particles behave? Think about superposition, entanglement, and all the other quantum magic. Got it? If you picked quantum theory, you nailed it.